Welcome to Parkinson's disease, the master class. This lecture will discuss the subject of alpha-synuclein and its role in neurodegeneration in Parkinson's disease. It provides the latest research on the state of development of natural modulation of this important protein in the physiopathology and possible treatment of Parkinson's disease. Presenting the information for this lecture is Dr. George W. Kukurin. Dr. Kukurin is a chiropractic neurologist with over 20 years' experience in treating complex neurological conditions. Without further delay, here is Dr. Kukurin.
All right, folks, welcome to this lecture where we're going to dive deep into the fascinating world of alpha-synuclein protein that plays a crucial role in the central nervous system. We'll explore its normal function and how things go haywire when it becomes malformed. We've got some exciting studies lined up that support the use of natural substances to tackle the pathological metabolism of this protein. So let's get started. First things first, let's kick off with a general overview of the topic. Once we've got that covered, we'll jump right into the studies that hold the potential to benefit our patients battling Parkinson's disease. So buckle up and get ready for an enlightening ride. Alpha-synuclein and the synuclein that is abundantly expressed in the nervous system, particularly in presynaptic terminals of neurons, while its abnormal aggregation and accumulation are associated with various neurodegenerative disorders, such as Parkinson's disease and Lewy body dementia. Alpha-synuclein is believed to play a role in normal nervous system function as well. Normal function of alpha-synuclein. 1.1 Synaptic function. Alpha-synuclein is involved in the regulation of neurotransmitter release and synaptic vesicle dynamics. It plays a role in the assembly of the SNRI soluble anethylmoleimide sensitive factor attachment protein receptor complex, which is essential for synaptic vesicle fusion and neurotransmitter release. 2. Regulation of dopamine synthesis and release. In dopaminergic neurons, alpha-synuclein is thought to modulate the activity of tyrosine hydroxylase, an enzyme involved in the synthesis of dopamine, and may also regulate dopamine release. Three, membrane curvature and lipid binding. Alpha-synuclein can bind to and remodel lipid membranes, which may be important for synaptic vesicle formation and trafficking for chaperone-like activity. Alpha-synuclein has been proposed to have chaperone-like functions, helping to prevent the aggregation of other proteins and maintaining protein homeostasis in neurons. However, it should be noted that the precise physiological functions of alpha-synuclein are not fully understood, and it is possible that it may have additional roles in the normal functioning of the nervous system. While alpha-synuclein is present in healthy individuals, its abnormal aggregation and accumulation in the form of insoluble fibrils or Lewy bodies are closely associated with the pathogenesis of various neurodegenerative disorders, including 1. Parkinson's disease. Aggregation of alpha-synuclein in dopaminergic neurons of the substantia nigra is a hallmark of Parkinson's disease and contributes to neuronal dysfunction and death. 2. Lewy body dementia. Abnormal accumulation of alpha-synuclein in the form of Lewy bodies in cortical and subcortical regions of the brain is a characteristic feature of Lewy body dementia.
Treatment options for Parkinson's disease currently focus on managing symptoms rather than addressing the underlying causes. However, there are ongoing studies exploring different approaches to target the neurodegenerative mechanisms associated with PD. These include promoting autophagy to clear aggregated alpha-synuclein, disrupting alpha-synuclein aggregation, suppressing inflammasome activation, and inhibiting apoptosis or programmed cell death in the nigrostriatal dopaminergic system of animal models with PD. Research suggests that alpha-synuclein shares similarities with prion protein, particularly in terms of its characteristics. Prion diseases are neurodegenerative disorders that involve the buildup of an abnormal isoform of the protease-insensitive isoform of prion protein. The fragments prion protein 16 to 126 of the human prion protein are responsible for most of the abnormal traits associated with the production of prion protein in the disease.
All right, let's begin by watching a video to give ourselves a moment to relax and prevent our minds from going into overdrive. Take a look at this video and see if you can spot any differences. And always keep in mind that the purpose of delving into all this intricate information is to ultimately assist our patients with Parkinson's. So let me know your thoughts. Let's start by familiarizing ourselves with some key terms that we'll be using as we delve into the studies on potential targets and pathways to improve outcomes for patients with Parkinson's. First, we have the alpha-synuclein monomer, which is the normal form of the alpha-synuclein molecule. Next, we have misfolding, which occurs when there is a malfunction in the endoplasmic reticulum, or ER for short. We'll also be discussing oligomers, which are formed when multiple monomers bind together. Here, you can see an example of 3 monomers binding to form an alpha-synuclein oligomer, which is where the development of pathology begins, the pathological inclusion body associated with Parkinson's and similar diseases is known as a Lewy body, which consists of fibrillated and clumped oligomeric forms of alpha-synuclein. This, in turn, leads to neural inflammation, the activation of inflammasomes and microglia. Now let's move on to our first topic of discussion, heat shock protein. Specifically, we'll be focusing on heat shock protein 70, which is responsible for relieving ER stress in the endoplasmic reticulum and is closely linked to the misfolding of the monomeric alpha-synuclein. Once we've covered this topic, we'll continue our exploration from there. The endoplasmic reticulum, or ER, undergoes selective degradation through a process called ER phagy, which is crucial for maintaining cell homeostasis. In Parkinson's disease, alpha-synuclein builds up in the ER, leading to ER stress and ultimately contributing to neurodegeneration. However, the exact role of the RA phagy in regulating alpha-synuclein levels remains largely unknown. Recent epidemiological studies have shown that echinacoside, or ECH, a phenylethanoid glycoside found in cis-tanch, can help prevent the development of Parkinson's disease. However, the specific mechanisms by which ECH protects against neuronal death are not yet fully understood. In this study, we conducted experiments to confirm that ECH has a protective effect on nigrostriatal neurons against 6-hydroxydopamine 6-OHDA induced endoplasmic reticulum stress, both in vivo and in vitro. The validated mechanism of cis-tanch, or ECH, activity was its ability to reduce the accumulation of CPN caused by neurotoxin 6-OHDA. CPN has been identified as a crucial molecule in motor neuron disease and has been closely linked to endoplasmic reticulum stress in numerous studies. ECH effectively mitigated neurodegeneration by promoting the degradation of sepin and alleviating endoplasmic reticulum stress. To investigate the effects further, rats were treated with neurotoxin ROT and co-administered with Kukurin for a duration of 5 weeks. Immunohistochemical analysis revealed a significant loss of dopamine neurons in the substantia nigra of rats treated with ROT. This loss was accompanied by an increase in the accumulation of alpha-synuclein and a compromised mitochondrial respiration.